Okay. So yeah, good morning all. So now the conformation of ethylene glycol. So here you see the conformation in the Newman projection formula. Okay. So in the ethylene glycol, here this is the anti-conformation here, right? So this is the anti-conformation. So anti means groups, right? All the groups are opposite to each other here. Okay. Here the hydroxy opposite, hydrogen opposite, hydrogen opposite here. So it is anti-conformation. And this one is a P Gauche conformation. P means plus here. Okay. Means it is on the right side, clockwise direction. So it is plus. And this is M Gauche, right? So Gauche means when the same groups are adjacent here, right? If the same groups are adjacent, then it is called Gauche conformation. Means the 60 degrees separation, right? The same groups are separated with the 60 degree here. The angle is okay here. If you see the angle is 60 degrees separation, right? Okay. So because here the two same groups, allied groups are on anti-clockwise, so it is minus here, M, and here is on clockwise direction, so it is plus the P. P Gauche. Both are Gauche only, but due to the uh, uh, position of the hydroxy groups, it is assigned as a P and M here. Okay, right. Now here you see among these, right, anti-conformation with P Gauche and M Gauche. So the stability order, if you see the stability order of this one, so generally, right, the Gauche conformation is more stable here because they are able to form the hydrogen body. Okay, so here in the anti-conformation, here both are far away, right? Both the hydrogens are far away, so there is no possibility for formation of the hydrogen bonding. So where it is less stable here, and these are the more stable. Okay? Right. Now here the conformations of diastereomers. Right. So the diastereomers. So what are the conformation of this one? And the the stablest compounds are the conformer and the highest stable and right least stable. So that thing you have to identify here. Okay. So first we'll see the meso compound here, right? The meso compound. So in the meso compound, right? Okay, it is meso. Why it is meso here? It is optically inactive. The meso compound is optically inactive, right? Because here a plane is there, right? So the plane of symmetry here, the sigma is there. Sigma is plane of symmetry here. Okay, plane of symmetry is present. So if plane of symmetry is present, so then it is optically inactive here. Okay, even though it is having the chiral center generally, right here, the how many chiral centers are there? There are two chiral centers are there, isn't it? Even though it is optically inactive compound, right? Because the mirror images means the plane of symmetry is there, plane of symmetry is present, sigma is present. So generally to exhibit the optical activity, all the symmetry elements, right, all the symmetry elements means C2 axis of symmetry, sigma, identity, right? So identity, all these are the symmetry elements, isn't it? So all symmetry elements must be absent. If any one of the symmetry element is present, then that is optically inactive, even though it is having the chiral center, so it is optically inactive here. So like that, here this particular glycol, right? So this glycol is, it is the meso compound, optically inactive compound. Okay, and here when you convert this right Fisher projection, right? So this is your Fisher projection formula, and it is converted into Newman projection here, right? So we have the various means presentation of the molecule, right? So here this is Fisher projection, and this is the Sahar's, okay, the Sahar's formula here, right? Sahar's formula, and this is your Newman projection. right? This is Fisher projection. So like that, the various means methods to show to write the molecules here, right? So the presentation of molecules. So you can present by Sahar's formula, the Fisher projection formula, or the Newman projection formula. And yeah, the Newman projection formula is very comfortable to study the conformational analysis here, right? So this is very comfort presentation to study the or to understand the conformational analysis here. Okay, right. Now you see. So when you convert this compound, right, the meso compound into a Newman projection. So where this is the front carbon, right? So this is the front carbon. This is the back carbon. This is the back carbon here. This is your front carbon, right? So the back carbon is, this is shown with the circle. This is shown with the dot here. This one, right? Okay, fine. So when you convert this into Newman projection formula, so where this is the eclipsed conformation, right? So this is the eclipse, both are same, right? So this is the both are same only. Okay, so this is inverted formula here, right? It is inverted formula. So both are same only. So both are the what is that eclipsed conformation, right? So where all the all the groups where these two methyls are overlapping each other, where that the theta equal to 0, right? Dihedral angle is the 0 here, 0 degrees, right? There is no degree of separation here, right? Here also same thing, with that theta equal to 0 here, 0 degrees. Here also same thing. So all the groups are the atoms are overlapping each other. That's why it is called the eclipsed conformation. And eclipsed conformation is higher energy conformation, right? The eclipsed conformation is a higher energy conformation. So higher energy conformation means least stable conformation, isn't it? Because the energy is, right, or the stability is inversely proportional to the energy, isn't it? The stability is inversely proportional to the stability. If higher energy, least stable, least energy, higher stable, right? So like that. So here this eclipsed conformation is higher energy conformation here, right? With the higher energy conformation. So least stable conformation here. Why it is higher energy? Because these groups, right? These groups are eclipsing each other. So they will suffer from the steric strain, right? They will suffer from the steric strain here. That's why where it it consumes or it takes more energy, right, to maintain this eclipse conformation. That's why it is higher energetic conformation and least stable conformation. Right now, okay. So this when these diols are, right, upon rotation of the back carbon, right, upon rotation of the back carbon. So by holding the front carbon here, right, so you hold this front carbon and you rotate this back carbon 60 degrees. Okay, you rotate this back carbon 60 degrees. Then what happens here? Where OH comes here, methyl comes here, hydrogen comes here. You will get another conformation. Okay, you will get another conformation. So then you will get this, generally you will get this particular P Gauche conformation. P Gauche means which where the two hydroxy groups are in the right side. And upon rotation, further angle of the degrees rotation here, so you will get the M Gauche conformation, right? So both are same only, but where the position of the hydroxy groups are different here, isn't it? So now it is M Gauche conformation here. And further rotation, right? Upon further rotation, you will get this anti-conformation here, right? Anti-conformation. So anti means here you hydroxy groups are opposite in the trans direction, and these methyls are in the trans direction. These hydrogens are in the opposite direction here. So it is anti-conformation, right? And if you see the stability, right, the stability of these conformations, right? Eclipsed here, okay, eclipsed, anti, and gauche, right? So these are the three conformations possible upon the rotation of the carbon-carbon single bond here. Okay, so in the acyclic compound, not in the cyclic compound, because the cyclic compound, the rotation is not possible, isn't it? Because the right, the groups, for example, it is a cyclic compound here, right? So if you rotate this one, if you rotate any carbon, then what happens here? The breakage of bond will be takes place, right? The breakage of bond will be takes place here. That's why the rotation will not be possible. Only thing is you can flip the molecule, flip the bond here, flip outside or the inside. So like that. And you can generate the various conformers. Okay, but here for the carbon-carbon single bond, the rotation will be possible. You can rotate either on clockwise direction or the anti-clockwise direction, or any degree of rotation you can do. 30 degrees, 60 degrees, yeah, right? 120 degrees, 180 degrees, 240 degrees here, 360 degrees. So that rotation is possible. Okay, fine. So now you see in the meso conformation, right? So in the meso conformation, you see these are the three conformers: eclipsed, para gauche, meta gauche, sorry, p gauche, m gauche, and anti-conformer. These are four conformers here. And among these four conformers, where these two are the stable conformers, right? Stable conformers, yes. Para gauche are the meta gauche. Both are equally populated. Both are equally populated here. Equianistic here you see, right? Equally populated. The population means the existence, right? Existence is equal. That's why both are stable conformers only. Now we will go with the active isomer, right? The previous one is above one is a mesoconformer, same compound only, but the isomer, the another isomer, isn't it? So right, so we'll go with this active isomer here, right? The active conformer. So in the active, we'll take the what is this? This is a uh, trio, right? Mm, erythrocyte, right? So where these hydrogens are on opposite direction here. So this is the erythroconformer here. Okay. So in this active conformer, again you will get here this is a cis means conformer, or you can say it is a eclipsed, right? Cissoid or the eclipsed conformer here, right? And another type of conformers possible is there is a para gauche conformer, okay, and meta gauche conformer. Sorry, p gauche conformer and m gauche. Plus p means plus, m means minus here, right? And here is a anti, okay, anti-conformer. Right. Now in the active isomer, so which conformer is a stable one? Okay. So now you see in this active conformer, right? Here, obviously what is it? Cissoid conformer or the eclipsed conformer is a least stable. Okay. And now you differentiate the stability between the anti-conformer and gauche conformer, right? So now here you see p gauche plus gauche conformer and m gauche conformer and the anti. So anti is a least stable here, right? So after eclipsed, the next least is a anti-conformer here, because there is no hydrogen bonding formation possibility here, right? And after that, right, in the p gauche and m gauche, right, you see here the p gauche is more stable. This is the more stable, right? So this is the more stable conformer than this one, right? The stability is this is more stable than this one. This is less stable. This is more stable here, right? So here the order is, okay, it is a P Gauche, then M Gauche, then anti, then eclipse. This is the order of the stability order of the various conformers of active conformation, right? Not meso. In the meso, where the P Gauche and M Gauche both are equally populated, equal stability. But here in the active conformation, where the P Gauche is the most stable. Why it is more stable here? Because you see here the hydrogen bonding formation is this, and you see these two methyl groups are right. The bulky methyl groups are in the trans direction or the opposite direction. So where the steric repulsions are neglected, the steric repulsions are removed here. There is no steric repulsion because these two methoxy groups or methyl groups are in the opposite direction, in the trans direction here. So it is more stable. Now, if you come to this M Gauche conformer, right, minus Gauche conformer, here also you can see the hydrogen bonding here, but these two methyl groups are adjacent, right? So you can see the steric repulsion, right? You can see the steric repulsion. They will suffer with the steric repulsion, right? And but here no steric repulsion because it is spatially separated here. So this is more stable than this one, right? This is more stable. Okay, then this one like this. This is the stability order. Right? Yeah. Now the conformation of two N comma N dimethyl amino, 1 comma 2 diphenyl ethanols. Right. So in the tertiary amines, okay, the tertiary amine compound. Here you see you take the trio isomer here. Okay, so trio isomer means where the two hydrogens are in the opposite direction here, and you see the hydroxy group and this tertiary amine group is in the opposite direction, trans direction here. And when you convert this Fisher projection into Newman projection, so first we generate this eclipsed conformation here. Okay, eclipsed conformation, and generally the eclipsed conformation is a least stable. Always it is least stable only. And right now the another conformer upon rotation of the carbon carbon right groups, then anti-conformer is a more stable. But if there is a possibility for participating of the atoms or the groups in the hydrogen bonding, then that will be the other conformer. Means other than the anti will be the most stable here. Like Gauche conformer is the most stable, right? So now here you see hydrogen is able to form the hydrogen bonding with the hydroxy group here, isn't it? The amine, right? The nitrogen means here the halogens like fluorine, okay, fluorine, chlorine, and hydroxy groups, amines. So these are able to form the hydrogen bonding, and other things are not able to form the hydrogen bonding. So, like here in these amines, you see, uh, and two phenyl groups are the disease direction, and these are gauche here. These are in the hydrogen bonding is possible here, and the two phenyl groups are in the opposite direction. Gauss are in the Gauss relations, and the hydrogens are in the anti. Here the phenyls are anti. Here the hydrogens are anti. Okay. So now you generally here the anti group it is least stable. Then they go to because the hydrogen bonding, right? And it won't be able to form the hydrogen bonding here. Okay, because spatially separated. And now and the peak outside where the two phenyls both are adjacent, right? So now you see right? So adjacent is more stable. Peak more stable. Erythro. Here the erythro compound. Right? The erythro means where the two hydrogens are in the same. So in the erythro also you see the conformers, right? Here the P gauge and M gauge. Okay. So here also same, right? So where you see the two phenyls are in the opposite direction, right? So the P gauge is the most stable here. And okay, right? So in the erythro also same, where the two phenyl groups are in the opposite direction. The two hydrogens are in the what is that? In the without. If the bulky groups are in the opposite direction, so generally there is a negligible steric repulsion between the bulky groups here. So that conformer is more stable. Next, going to the conformation of 2,3 dibromobutane. Okay, so dibromobutane. So here you see generally there is no atoms or groups are right? So they won't form the hydrogen bond. Only the fluorine can form the hydrogen. Fluorine and chlorine form the hydrogen bonding. But here the bromine, it unable to form the bromine and iodine. They won't form the hydrogen bonding. Isn't it? So in this compound, the anti-conformer is more stable. So first we'll see the mesoisomer here, right? So mesoisomer. Okay, so in the mesoisomer, you see where this right. So here, when you bisect this molecule, when you pass this pass the molecule, it's a molecule into two equal halves, which are mirror image. it can achieve the various conformation by rotation of the cis single bond. This relations the get the P gauge, M gauge, and anti. P okay. In the okay, so these two bromine and these two what is that adjacently, right? So you will see the steric repulsion between these two methyls. Okay, so here you can see the steric repulsion, right? So here you see the steric repulsion here, and here you see both are in the opposite direction. So there is no steric repulsion. Steric repulsion is negligible here. So this is 80, right? 80% populated here. More stable here. Population means the stability, right? And we call in the other what is that field, we call it is a yield. Okay, population, other populate. In the stereochemistry, we call the percentage of the molecule or the yield formation of the product is called population here. And in the other chemistry, we call that is a yield. Okay, in the synthetic chemistry, we call it is a yield. So this is okay. This is formed as a means major compound. Anti-conformer is major, remaining on the minor. Right? And these the P gauge and M gauge both are with equal population, equally populated. Means both are existence. Population in the sense the existence or the formation, production, right? So equally formed here because both are having same factors. Both are having same stabilizing factors here. So here you see the okay where this steric repulsions, right? So that factor is affecting on these the conformation. And here all the factors, steric repulsions and some other Gauche interactions here, right? Here you see the methyl Gauche interactions, bromine Gauche interactions are there, and the steric repulsions are there. So it is less stable. And here Gauche interactions and steric repulsions, all the destabilizing factors, all destabilizing factors are negligible here, right? So it is more stable here, and these are the less stable. Okay, now we will take the active conformation here. So in the active isomer, right? So we'll see this what is that trio. Okay, right? So here in this is the eclipsed. So generally eclipsed is always the least stable here, the last, okay, the least stable compound. And now the P Gauche conformer and M Gauche conformer and anti-conformer, right? Now you see in the active conformer, now you see the P Gauche conformer, So in the P Gauche conformer, so what are the destabilizing factors are present? And in the M Gauche conformer, what are the destabilizing factors are there? Now you see there, right? So in the P Gauche conformer, you see bromine Gauche interactions here. Bromine Gauche interactions, and what is that? Steric repulsions are there. And here also methyl Gauche interactions and steric repulsions are there. So it is less stable. Now in the M Gauche conformer, okay. So you see here, these methyls are in the anti-direction or the trans direction here. Okay, the methyls are in the opposite direction. So methyl Gauche interactions are neglected, right? There is no Gauche methyl Gauche interactions. And here the bromine Gauche interactions are there. So only one factor is affecting this conformation. Okay, means where the methyls interaction is neglected. And in the anti-conformer, okay, so in the anti-conformer means here where these bromines are in the opposite direction. Okay, so here you see where the methyl, right? The methyl, what is that? So Gauche interactions are present, right? And here the hydrogen Gauche interactions are there. That's why here these are in the opposite direction, and these two methyls are bromines are okay. Means Gauche orientation here. So this is more stable, and this is less stable here. Then this is less stable, right? So this is first stable compound, right? Then this is a second stable compound. This is the third stable compound, and the eclipse is a least stable compound, right? So why only thing is because the methyls groups are in the opposite direction, right? That's why it is more stable, right? Next, one more confirmation analysis is a stilbene dibromide, right? Here the stilbene dibromide here. So what we are doing here? So where we are keeping the same bromines here, but in place of methyls, we kept the phenyl groups. Means the methyls are substituted with the some other bulky groups like phenyl group here, RL group. The RL group is bulkier than the methyl, isn't it? So what is the fate of these conformers and which is more stable when you replace some methyl with phenyl? So you see here. Okay. Now the meso conformation, right? Here the eclipse generally it is always least stable here, and in the P plus Gauche conformer and M Gauche conformer, right? So only thing is just you observe how the same groups are oriented or attached here, whether they are oriented oppositely or uh, same so the attributes and you it with some least stability. Okay, so like that. So you find here, here the phenyl bromine. So